So deceleration becoming more and more prominent discussions, whether you talk to practitioners, whether it be social media. So hence getting you guys on to provide some information on the training and testing of deceleration, which I'm really looking forward to. So Damian, you're going to kick us off first. From a research point of view, what does it say? How important is deceleration, and what do we know about this topic?
Yeah, cheers, Rob. Thanks for the invite onto this. It's a really interesting topic. I think I'm quite biased on that as well. I think because I've been looking at this area now for probably 7 or 8 years. So yeah, I think it's a really important area, one which has been largely overlooked in the past. And I think there is, like you said, over the last few years, really, I think there's been a big impetus on trying to drive some better understanding of this task. So I think it'd be useful, I think, for the listeners and for me as well, just to put across what I think deceleration is before we get into the importance of it. I mean, when we look at deceleration from a movement outcome, we're typically looking at trying to improve the athlete's ability to reduce their speed with respect to time. Now, from a movement outcome perspective, obviously we want to try and increase the athlete's ability to get higher rates of deceleration from a movement outcome perspective. But it's also important, and I think this is where it's really interesting in terms of the element of braking or deceleration as a movement skill. So with deceleration, it is a really complex movement skill, and I think we've got to acknowledge that there is a real fine interplay between the limbs in how we coordinate the limbs to be able to apply an effective braking force. So that ability to be able to coordinate the limbs, to be able to switch the limbs, to be able to orientate the braking forces is really critical to, one, applying the forces, but then once we've applied the forces, being able to, and this is where deceleration becomes really important, being able to safely attenuate the forces during deceleration. So when we look at those two components, the movement outcome and the movement skill, we've recently proposed a definition based on those two factors, that deceleration should be considered as the ability to reduce momentum in accordance with the objectives of the task and the constraints, whilst skillfully attenuating and distributing the forces associated with braking. So we've highlighted there's two key components that we're probably going to get into talking about during this this discussion, because I think we've got the braking force control, the ability to control braking forces, but then also the ability to be able to attenuate those braking forces. And I think that's where we start to get into the importance of deceleration from those two perspectives. So we've got a performance element, but then we've got this injury risk element as well, which is where I think deceleration becomes really important. So yeah, if we start to get into the importance of deceleration and why we need to train it, I always say it's important to start from the game perspective and look at the demands of the game. Some of the stuff we did quite early on in my research, I found quite fascinating, because what we looked at was the game demands of accelerating and decelerating at high intensities. And what we actually found was quite surprising, actually, that in most team sports, when we monitored it with GPS above a high intensity threshold, most team sports had greater frequencies of decelerations, high intensity decelerations than high intensity accelerations. And that was in football, soccer, most codes of rugby, Australian football, hockey, with the exception at high intensity was American football, was the only sport which had that exception. So that was quite an interesting finding quite early on in my research, which identified that decelerations are really highly frequent. And obviously those decelerations are obviously critical within, the attacking and defensive actions within team sports. Particularly from a creating space perspective or closing space down perspective, decelerations are really, really critical in that space, because we can generate really high rates of change in velocity. So yeah, from a frequency perspective, very highly frequent. And then the other area which we look at with the game demands and the action of deceleration itself is the forces, the mechanical forces. And this is where deceleration becomes really distinct from other movement actions. We could probably, say that deceleration is probably the most mechanically demanding task from a force perspective, from a loading perspective. So if we're backwards engineering in terms of the demands, we need to prepare athletes, team sport athletes in particular, for these demands, these high forces. We're looking with deceleration potentially up to 6 times body mass in some of the braking forces, and that's in really, really short periods of time. So you could be looking at less than 50 milliseconds. So really high loading rates, really high magnitudes of forces that athletes need to be able to, one, produce, but then two, be able to tolerate those and attenuate those forces throughout the lower limbs. So those forces are really high, and obviously they repeat them very frequently. And that was something which we put together in a model and said that then generates quite high risk of tissue damage for athletes. And that risk of tissue damage can potentially alter the way the athlete moves during gameplay. So it can alter other movements that may be important, such as sprinting, high-speed movements, because they're trying to manage them deceleration forces. They're trying to protect the tissues from damage. So yeah, I think from a forces and from a frequency perspective, if we can improve our athletes' ability to one, perform frequent high-intensity decelerations, and then to be able to attenuate them and reduce tissue damage from them, then we certainly we're in a position where athletes are going to be able to maintain speed and in attacking and defensive actions, be able to be successful in those movements. Some recent work in soccer has shown that decelerations are highly frequent, for example, in preceding goal scoring opportunities. And that's, you can see that in like attacking movement plays, but also really important for defensive plays as well, that they can obviously quickly respond to the opponent's movements. So I think really, really key for these, match winning actions as well, in many sports that we see.
One question before I ask Mark about the testing of deceleration based on what you just said, Damian. Through your conversations with practitioners, based on everything you just said for the last few minutes, is deceleration getting the time in the program that it deserves? Or is it still, are we still understanding and it's still kind of this build up of momentum, I guess, to have that integrated well within a program?
Yeah, it's going to be definitely, sport specific as well. I mean, if you look at soccer, for example, in the UK, small-sided games, medium-sided games, large-sided games are, very, very popular training methods throughout the microcycle of the training week. And those type of activities do expose athletes to a high frequency of decelerations. However, I think what we perhaps haven't got as good a knowledge of is how we can actually improve the coordinative elements of the task, and how we can perhaps improve the athlete's ability to perform those decelerations outside of those type of game scenarios as such. Like we have had for acceleration, with resisted acceleration work, for example, and other exercise types for acceleration. I think we're still kind of like developing knowledge in that area for deceleration, I think.
Perfect, thanks, mate. Just bring Mark into this, and Ted, feel free to jump in whenever. Testing deceleration, Mark, what options have we got? Is this an area that is developing? From my experience, it's maybe something that was integrated within other tests, but now it seems like it's becoming a test within itself due to different tech being available. What options have we got in 2022 to measure deceleration with our athletes?
Yeah, I think the options are definitely growing. I think, it's interesting that, Damian spoke on, the safety aspect of braking, when you're determining braking strategies. I think probably the vast majority of when we actually were trying to quantify or objectify braking strategies and things like that was probably in the return to play process. As you're slowly progressing those demands over time, not just the actual braking forces themselves, but directional pattern of it. What type of foot plant was it with those braking strategies? I think we did a lot of that in return to play, but I don't think it's been as popular in the team setting, probably because there hasn't been as much, I think, access to good technology or a really efficient way to test in a full team setting. The first thing that we look at, obviously, when we do any testing or assessments, is what are the metrics that we're looking at that becomes actionable? What are we going to find? What are our key performance indicators for this movement that are actually going to help drive decision-making process when it comes to the interventions or the program itself? So really what I look at, like from a deceleration standpoint, if you're going to do some kind of assessment, is what is the deceleration distance? What's the deceleration time? What is the rate of deceleration? That's a difficult thing to test. I think now, we've been fortunate. We have the LedgeRack Pro device, which is a radar timing device. So it actually gives us the rate of deceleration. So now we can kind of see what the braking impulse is. And then early versus late. So like, again, is a safer strategy. So more time spent in that early deceleration, or are they truly coming from a really high entry velocity and braking really quickly? So those are the things that we look at from a deceleration standpoint. But then you also have to look at most of our movements in sport is never a true dead stop. So a lot of it's built within change of direction testing, right? And we've always done, I think, 5-10-5 and T-test and Elger, like all those have always been built in. But I don't think we've ever really looked at it as deceleration, right? We look at it as what's the total time? What's the speed of how you can do those tests or drills? We really need to look at, again, what are the braking strategies? How well do they decelerate? And then what's their reacceleration look like? So, we have our deceleration KPIs, and then we have our reacceleration KPI. So what's our reacceleration time? What's the rate of acceleration during that reacceleration? And from a testing standpoint, in a team setting, it is a little bit more difficult, but the ADA test, obviously, that Damian's done a whole bunch of research on, is probably the easiest one to do in a full team setting, because we'll just have your athletes sprint for 20 yards and they don't break until 20. And then it's really easy to track what was that deceleration distance. The time can be a little bit more difficult. Obviously, you're probably gonna need some kind of video analysis to determine what the true time of deceleration braking was, but you're always gonna have that deceleration distance. So again, if I'm gonna provide different interventions and make sure that they're responding well to that stimulus and they're actually improving, at least we can work off of, are they shortening that deceleration distance over time? That's easy to do in a team setting. The difficult thing from a limitation standpoint is what was the entry velocity. That's a little bit harder to determine. Obviously, in a predetermined test, they know they have to brake at some point. They're probably not going to hit their highest entry velocity. Well, what we found with our testing devices is when we do the ADA test, typically we're looking at 85 to 90% of peak velocities coming in. So it's not a true max test, but again, I think it's difficult to make it a max test when there is a predetermined braking spot. So the ADA test, I think, is really easy to do. For the most part, it doesn't require a whole lot of technology. Obviously, if you have video analysis, if you have radar and things like that, timing gates will always help. But a lot of what I really like to do from a deceleration standpoint is a 10-5 and a 15-5 change of direction test. So 180 degree cut, start with a 10-5. Usually the entry velocity is around 70 to 75% of their max velocity. But we see, again, from a safe strategy standpoint, it's less braking loads, less braking forces. Usually we're seeing with our devices around -5, -10 feet per second squared as the rate of deceleration. And then when we get to a 15-5 change of direction test, now we're touching again more closer to that ADA test, so around 85% max velocity. And now the rate of deceleration is much higher. It's kind of -10 to -15 feet per second squared, so pretty high. And we can kind of dictate, again, what is the reacceleration pattern, right? What movement strategy are we going to provide? And then take a look at what's limb-to-limb symmetry on that. Are there any movement limitations in terms of sprint to a back pedal, in terms of turn and sprint, crossover sprint, those different types of movement category selections that they have, and limb-to-limb on that, to really determine, okay, what are the buckets that we need to fill or areas that we need to address from an intervention standpoint. And then a test that I've really enjoyed that we just started to do, again, because we have that device, is add a chaotic change of direction with a predetermined deceleration test. So there's a master checkpoint setting that essentially goes out to 80 feet, so 26 yards. And what we'll do is when the device cues them, they sprint and they hit their max velocity. They don't know exactly when they're going to have to brake and redirect back to the device. We'll give them that cue, whether that's auditory or visual. But what we've seen is closer to 95% max velocity on that brake itself. So those impulses are significantly higher. And I think we get a pretty good indication of what their probably max potential of deceleration is from that. And it's usually somewhere between that, 15 to 26 yards. And then when they sprint back, they'll actually try to decelerate exactly on what the checkpoint or start position would be. So we get that change of direction plus a true deceleration in the same test. And we've seen significantly higher max velocities going into it. So again, I can compare that with the 15.5 and things like that, really just determine what are the braking strategies. And I think that really helps us if we know what our key performance indicators are for those. What are the, again, interventions that we'll discuss later? What are the interventions and why are we doing those things? Because, to your question, I think of Damian, are we training this? I don't think we train it as much as we should, because it is a really important aspect in all of team sports. But I think it's because we're not fully sure what we're looking at, and we haven't really figured out the best way to truly look at it and assess it.
With those percentages of max velocity, if it doesn't hit that specific benchmark, are you voiding the test? Are you going that far? I mean,
I haven't built enough data yet on that. But again, it's because the hard part with the newer test that I'm doing, where it's more of a chaotic cut with a predetermined, you don't know the distance is always going to be variable, which is a huge limitation, but I know the entry velocity. So ideally, if I can get as close to above 90% of an entry velocity, I think it's a relatively valid test. So I think that's probably the hardest part, though, is like, if they hit 85%, do I really look at it? Because again, it's a lot easier to brake quicker. The deceleration distance is probably much less because the entry velocity is much less. So yeah, I have to really figure that out. But so far for that test, if it's below 90%, I'll just void that and make sure that it's at least at a 90% max velocity to be relatively valid.
You kind of answered it, but I had to follow up on that one, Rob. So Mark, when you're doing that, how much strategy change do you see between, say, 80% entry and 90%? Significant, I'm sure, but way less than 70% to 90. So right. 90% is a good cutoff, but is there any justification? Maybe it's 85, maybe it's 80. How much is that strategy changing?
I mean, the strategy changes, I think, quite drastically. Like in a 10.5, you really don't lower your center of mass too much. Like the total range of motion on the braking strategy isn't really great. But then you look at that where they're hitting closer to 95% of their entry velocity, they really have to drop their center mass to receive and break those forces and redirect them. So you see a huge level change. And it's significantly more sporadic. And I think because especially the chaotic version, you start to see, I think, more poor kinematics because, again, they don't know when they're going to brake, so they're not preparing for it. But you see a lot more excessive forward trunkling. I mean, they're just throwing their torso way out in front of their center mass to try to decelerate, which obviously is going to lead to higher risk of injury. But that's good to know because now we can hopefully address it a little bit better in whatever kind of intervention or drills that we'll use to try to train that.
Is there, and I know you said about the incorporating video into Damian's ADA, but with deceleration more than any other quality, is the qualitative aspect just as important as putting a number on it based on their ability to not only decelerate but reaccelerate as well and be in a position to be able to do the next most important thing? I don't know, chase a defender or go and attack.
I think so for sure. I mean, that's the vast majority of the movements that we make in a team sport setting. It's never just like this straight from a static start linear acceleration. You're always coming out of, and I think, like transitional movements, right? So coming out of a defensive jockeying position, then accelerating, then braking and redirecting, as Damian talked about, creating space and closing space from a change of direction standpoint, those are probably the predominant movement actions that they see in the sports setting. So the kinematics and how you're actually moving within those, I think, are really important that we should continue to track and make sure that we're improving those, because over time, those are going to be those huge energy leaks where we're going to see a higher increase in injury risk if those movement patterns are really inefficient. And we know they have significantly higher braking forces than acceleration does. And they continue to get high frequency and exposure to it. We really need to make sure that, I think video is probably the king from that standpoint, because we can look over time and make sure, again, are they responding well to the intervention we're providing, and are we putting them in a more advantageous position to receive these demands, repetitively.
Cool, thanks, mate. I'd just love to get Ted in on the testing question as well, to see if there's any specific test that you've used in your current setting or previous settings on to get an idea of the quality of your athlete's deceleration.
Yeah, absolutely. And I'll start with thanking you, Rob. Just really appreciate the opportunity to be here, especially with these guys. This is awesome. Really, really respect both these guys. So it's cool to be on here. I mean, there's a lot of stuff. Obviously, from a force plate perspective, there's things you can do. Now, that's a vertical plane, depending on what type of force plates you're utilizing, if you get the horizontal component. For us, we've utilized a lot of stuff from that standpoint, just to look at rate of force development eccentrically, looking at braking impulse and some of the things that Mark alluded to. There's 1,000 things you can pull from and detract from that. Other devices like the 1080 Sprint, Leeds React has a great new device. So you look at some of the things that you can get from a true braking component. Those are all things that we found value in. Just like anything else, are you getting 100% from one thing? No, never. But also, are those little keys and little things that we can put into the bucket? Absolutely. But those are some of the devices that we found a lot of value in. Even using GymAware with certain components and making sure that we're looking at specific speed variables of specific movements within the weight room too, Rob. I think you can pull a lot of things from some of the technologies out there that are available.
Cool, thanks, mate. I'll come back to you in a second with the question that I'd fired over to you. But Damian, from a research point of view, when it comes to testing, is there anything that is out there that has got any kind of bulk research behind it when it comes to decel or not?
It's quite thin, Rob, to be honest. Yeah. I mean, just on the back of what Ted and Mark have just been discussing as well there, I think one of the most important elements when we're considering any kind of test is to ensure that we can obviously reproduce that and we can get reliable data. And that's one of the pitfalls I think we've had previously with deceleration as well, particularly from a measurement perspective, that the devices that we've been using haven't been sensitive enough to capture such high changes in speed. So I think that's where the new technologies that Mark's mentioned about the LEDs React and a lot of the radar laser technologies, the 1080 Sprint, offer new opportunities, I think, to be able to get the deceleration values reliable and repeatable with your athletes as well. And I think that's really key. If we want to monitor changes in athletes' deceleration qualities, we have to choose metrics which are the most reliable and can detect the smallest changes in the athletes' improvements in their deceleration capabilities. So that's where some of the work I did within the research perspective was to try and come up with a test that was reliable and could be reproducible. And that's where we found metrics like average deceleration were probably some of the best metrics in terms of reliability, because it had the smallest variation from test to test. So I think that's really important, because some of these tests I see with deceleration, where we start to try and make things highly specific to the game, we completely lose the reliability and the ability to repeat that test. So it becomes a pointless exercise, in my opinion. So I think that's where the ADA test, the acceleration deceleration ability test, allows us to get a reproducible entry velocity of the athlete, very within a very small threshold. So we're looking at with the research we did, if we had a 5% cutoff from the 20-meter normal sprinting speed without a deceleration, we were able to repeat their speed within a CV percentage of around about 2%. So we're getting very reproducible entry velocities and distances when the athlete starts to decelerate. Now, as we mentioned before, the entry velocity completely changes the deceleration strategies. And that's where it's really difficult with deceleration, and it's a much harder task than what we've had with acceleration, to be able to get a reliable deceleration assessment of the athlete. And I think, just summarizing what I talked about, we can do that in a linear task, or we can now, some of the work I did recently with Ola Erikstrud at the 1080 Sprint, we were able to show that the 1080 Sprint during a 505 was providing very valid results compared to a 3D Qualisys motion cameras. So we're able to get, really accurate velocity data coming in and out of the change of direction, and then be able to identify the phase-specific information, which is what we want with the deceleration. And the importance of being able to get the peak velocity of the athlete, the moment when they start the deceleration. I think that's critical for any reliable assessment of deceleration capability, the ability to know when the athlete has started to decelerate. So yeah, I think the research is certainly increasing in that area with the more technologies that are becoming available, and I think that will be a big area, I think, in the future, once we get more people utilizing that and trialing these tests out with their athletes. I think one last point I would make, and there's a lot of discussion around, we should be making athletes faster without knowing what their deceleration capabilities are, or don't speed up an athlete that can't slow down. Well, for me, that's where I think it becomes quite powerful, because we can start to look at the ratios between their acceleration and their deceleration capabilities to get some kind of understanding of where the maybe training deficiencies are, and whether they can slow down, what they can speed up. An example of a cheetah there, some of the work that was done with cheetahs found that they had a 60% buffering capacity above their acceleration. So their deceleration was 60% greater than their acceleration capabilities. So for me, that's quite interesting. I think that is going to vary massively with different athletes and different positional roles. That ratio of accel to decel.
Were you going to dive in there, Ted? If not, it's fine.
Yeah, Damian actually touched on it, because the difference between some of the motion capture technologies and obviously what we're able to do with like 1080 sprint, and even a guy you've had on here too, Rob JP Brand, you look at some of the things he's been able to do with the 1080. In an ideal world, you strap them to a 1080 or a Leeds React and you run them into a motion capture system, because some of the new cameras that are about to come out, some of those 8K cameras, Kinetrax is a company that's coming out. They're doing a lot of stuff in baseball that's got incredible potential. You look at that in an ideal world, because going back to another point Mark made, what's the ultimate goal? What are we trying to accomplish with deceleration? Well, once you decelerate, you're attempting to decelerate, control your body in opportunity to go into your next movement, which is the next most important movement. So for me, getting them into that position, being able to see the sequence, see joint angles, and then it goes into 1,000 different rabbit holes. We just increased this athlete's dorsiflexion by 10 degrees. Okay, what angles is he allowed to get into now? What's the center of mass look like coming in and out of this cut? So I think as you start to look at the technologies and the testing opportunities that we have, it's exciting to think about what's coming, but we got to get a handle on where we're at right now. And those guys make great points to that.
Just before we dive into the kind of technical aspects and how we actually improve it, Ted, physical qualities needed to decelerate effectively on the field or court, I think, is probably a nice place to start before we jump off into actually how do we develop the two aspects that Damian talked about at the start.
Yeah, absolutely. And when you look at deceleration, what is the factor that controls a lot of it? It's motor control. What's your ability to control your center of mass? Just like what we're talking about. You could have limitations because of joint structures. You could have limitations because of strength deficits. So for me, it's the opportunity and the ability to decelerate your center of mass and to properly put it in the correct position for your next movement. Once again, what's the goal? Deceleration. The goal is to get you into position so that you can reaccelerate and apply force into the ground in whatever direction you're attempting to go. And it could be through an opponent or it could be into a direction in air. So for me, your ability to decelerate your own forces, your ability to brake, get into the proper angles. With that comes eccentric strength variables. Obviously, you have to be strong enough. You have to have the ability to exert force into the ground at the proper angles at the proper time. There's a sequencing component. So now neuromuscularly, what's your efficiency pattern? Do you understand how to control your body weight in multiple angles? Once again, when you look at how many times in a football game, American football, or in a soccer match, how many times does an athlete run exactly linear and just have the opportunity within 5 yards to break? Not often. So you look at that, it's multi-directional. It's your ability to create and reduce force in multi-directions. So for us, it's that over and over and over again. And then we throw in the component with other athletes. You have to also have the eccentric strength capabilities to decelerate an athlete who's trying to accelerate through you effectively. So now there is a concentric force component. There's a relative strength component. Now it's just not body weight, but on top of that, when you throw in the other variables of sport across many disciplines, those are some of the things that are obviously hugely important for an athlete to have when we're talking about deceleration.
So we talked about eccentric strength there. I don't want to make this an eccentric strength kind of roundtable, but it seems such an important aspect for this topic. Ted, when you're developing eccentric strength in the gym with deceleration as the kind of reason why that's there in the first place, what does that look like?
Yeah, great question again. I think some of the things that you're looking at, Rob, are obviously just your ability to control loads eccentrically. So with that, there's tempo training that you can do. There's 1,000 different things that you could do from a purely eccentric loading standpoint, but also the opposite end of the force velocity curve. You have to be able to control weight and load, whether it's your own body weight or something through an implement like a Kaiser power squat, rapid eccentric braking technology. So for us, we'll actually put them in a Kaiser power squat and have them break fast rate, but you got to be able to control the load, and then we can progress that load. Then we can track how they're turning that on if we really wanted to go through it, and then draw it back into a re-acceleration phase. Whether it's a unilateral exercise, we could go back into a unilateral squat, for instance. So for me, there's an opportunity to reduce force and actually reapply that, which again is the ultimate goal of deceleration. Get yourself in a position with the ability to overcome the resistance or the load and to re-accelerate through something else. The other thing, I mean, we start very, very basic. When we start our programming, we just completed our off-season training program. For us, we start very, very basic and simple with controlling your own body weight. So we're going back to wall drills so we can start statically. Then we're progressing into plyometric progressions where we are jumping, but we're locking in and efficiently loading, but then receiving force. So for us, it's sticking landings in unilateral directions, multi-directions. How do you land on one limb? How do you land on two limbs? From a lateral cut or from a crossover movement? How do you decelerate on one leg if we have to stick you into a cut angle? So we're starting very, very basic and teaching our athletes how to receive force through their own body weight. Jump over a mini hurdle, show me your strategy and show me how you can control your center of mass when you're just landing on one limb. So for me, we start very simple with that. And that's a lot of the ballistic eccentric stuff that we do. And then obviously we can progress that, whether it's with loads, different heights, different movements, or different angles where we're coming out of a movement or going into a movement, Rob.
Perfect. Thanks, mate. I'd love to get Mark back in from a gym interventions, gym-based practice when it comes to the transference of that to improve deceleration ability. Where's your mind go when it comes to the programming side in the gym?
I mean, I'd say really similar to Ted's. Obviously, I think you do have to really start basic in terms of the patterns, and then build and progress in terms of specificity. So we'll do a lot of, like, from a plyometric standpoint, work through lower elasticity, then working more reactive strength, and then higher shock method type eccentric loading. But then I think you really have to get into trying to mimic what those change of direction angles look like. So a lot more, I think, unilateral plyometric exercises. Try to progress the actual eccentric load. So whether that's, again, dropping off of higher boxes onto a single leg and having to redirect, or adding load to those things and those patterns. What we really utilize quite a bit is our K boxes, isoinertial training. We found really high success with that. And again, it's really nice because we can track with the K meter, like VMAX Pro, you can put on there as well to try to get some better metrics or data on it. You can really mimic, in terms of just a squat pattern on the K box, you can mimic what the unweighting and breaking RFD is on a counter movement jump with the K box. And we can see that those are relatively the same Newtons, and then you have to redirect those. So, I think Damian's point of where that deceleration ability has to be much greater than your acceleration. We're hitting 120% greater eccentric peak powers on our isoinertial training compared to the concentric outputs. So we really utilize that. It's super user friendly. It's really easy for the kids to understand and learn. Obviously, you're not going to start with those methods right off the bat, but once we feel pretty confident that they've mastered and they have high competency of those patterns, try to put them in isoinertial training. Full range of motion to start, because obviously you're going to have slower speeds and obviously less eccentric peak power from that standpoint, and then make it more joint angle specific to those various change of direction patterns or movement categories.
Can I throw this your way as well, Damian?
Yeah, just some echoing the points on the eccentric strength. I think, you know, that's something we highlighted in our recent review on the biomechanical and neuromuscular requirements of deceleration, that there's certainly, you know, specific eccentric strength qualities that are needed for deceleration. And we highlighted eccentric peak force, eccentric velocity, and eccentric braking RFD, or eccentric deceleration RFD. So training strategies in the gym that can target those qualities, I think, are really, really important. And you know, Mark and Ted have touched on a good number of good examples there. I'm also a big fan of, you know, flywheel technology to be able to give that eccentric overload. And I think that's a key part of the training strategy, is that eccentric overload element, to try and get that added eccentric, to augment the eccentric forces and increase the ability for that athlete to be able to resist and control those eccentric movements. So I think flywheel for me is quite a specific stimulus there, because the athlete's trying to resist that downwards movement, whereas normal traditional load, you're trying to control the movement, more controlling that movement down rather than trying to resist it, which is quite specific to deceleration. So I think the flywheels also have the advantage of being able to load horizontally. If you've got the pulley devices, you can do some really fantastic braking exercises there in the horizontal plane as well. So I think that's really important from a gym-based perspective, the combination of horizontal and vertical loading. And like we've been saying, it's a multi-directional element as well. So being able to, you know, increase the eccentric load in the lateral and the frontal plane is important as well, I think, for the athlete to develop them qualities, them eccentric qualities. Another training intervention, I think I'd just mention specifically here, I think, which has got some nice applications for deceleration, is the isometric loading strategies. So I think the isometric yielding or quasi-isometric loading movements can be really powerful for deceleration, particularly for targeting the tendon structures. And I think for deceleration, the tendons are really, really important. The connective tissues are that first line of defense. So they're really important from a buffering perspective. So how we can improve them connective tissue qualities through isometric training, I think could be a really powerful stimulus for deceleration. And you get a similar kind of eccentric loading with some of the isometric yielding exercises if we go for the long duration holds as well, where we can perhaps increase the ability for the athlete to kind of like yielding capacity to be able to resist that deformation. So your isometrics, and then going across the spectrum, you know, your yielding exercises for me will be down at the fundamental, the elementary, but then as you start to move up and you start to get more neural based, I would start to think about some braking isometrics as well, where we can target some of the braking specific positions, and we can start to do some of the more fast isometric or explosive isometric actions and target, you know, interlimb braking positions using overcoming isometrics. So that's, you know, I've certainly been inspired by some of Alex's stuff on that with the running isometrics, and just trying to flip that and think about how that can apply to braking. Braking isometrics is what I've referred to it as. So yeah, I think those two components, and I mention, as we've been saying, about eccentric landing control, basic landing exercises, and reactive strength as well being a really key quality for deceleration. Because of that pre-tension and that ability to pre-activate the muscles prior to contact with the ground. So yeah, reactive strength, isometric strength, really important qualities as well there to develop in the gym.
Yeah, I'll jump on that too, because I think I don't want to gloss over the importance of the isometrics, because that's a great point that Damian brought in. That's the first thing that we do after a season and we start ramping up our early off-season training. We go straight into isometric strength, and it's for exactly that reason. The connective tissue, the tendons, they have to reset after a grueling 6-month season, maybe a month or two off, and then we start to slowly progress back up. And then the first thing we do in our true off season, we're putting them in positions of lateral loading, of unilateral loading, of linear loading in deceleration specific positions. So it's against a wall, but you're in your cutting position. And now we can load you isometrically, and then we can progress into eccentric movements. And then after we get you to a point where we feel that you are adequately prepared, now we're going to go ballistic. We're going to start to do jumping to loading to landing, and then redirecting. And then we can work reactive strength, and we can work into some of those components. But I think it's important to note, the timing of all those things. Everything has a purpose, and everything should be married to that season. But keep the main thing. The first thing that we do, train for the joint and the tendon health. Make sure that that's ready before you progress to the next stage.
Cool. Thanks, mate. Just a bit of a reminder, we'll get into the kind of last 15, 20 minute area. So if anyone's got any questions, fire them in the chat or the Q&A. If not, we'll just plow on through. One thing that I think is really, really interesting on this topic, and it's the on-field interventions, but it's the technical improvements, like Mark said, like Damian said, like you all said, how important that is. So I'm going to come to you first, Mark. I know it's a big area, and it can be difficult to showcase without visual examples. But when it comes to making technical improvements, is there any go-tos that you would recommend coaches use with our athletes when it's trying to develop them technical aspects of deceleration?
High frequency, high exposure to it. Obviously, because it is so demanding in a sub-maximal setting. So a lot of times, we'll keep our high days and our low days. But on a low day, it's really easy to do a lot of sub-maximal change of direction work. And as you're teaching that, we'll put our athletes on heart rate monitors and make sure that we're in that kind of zone that we want to be in from a training perspective for conditioning standpoint. But we'll expose them to all the different cutting patterns, all the different change of direction patterns. And every time they only go out about 4 yards or 5 yards, and they have to stick every single plant essentially and hold that position. Then we can coach that position. You're also getting some kind of isometric exposure to that. So you can kind of work on some force at zero velocity when you redirect out of that angled position from a change of direction standpoint. But you can coach a lot. They get a lot of high exposure to that. We have what we call 4-8-12. So you'd sprint to 4 yards, you plant stick on your right leg, you backpedal back to 0, sprint to 8 yards, plant stick on your right leg, backpedal to 4, and then you go out to 12, plant stick on the right leg, backpedal to 8, and then sprint through. We can do that on a whistle. It can be cadence, and we can really coach it. And we as a coach can see those different patterns, those different angles to make sure, again, we don't have excessive trunk lean. We can make sure there's not this huge deviation of center of mass as they roll through from a plant position. If they stand straight up to backpedal, that's obviously not a very advantageous position to be in. And then you're redirecting that center of mass. That's just energy leak after energy leak. So really fatiguing from that standpoint. So that's a go-to for us. We do that, sprint backpedal, shuffle, turn and sprint, crossover sprint, or lateral run positions, and just really stick every single plant, at the 4, the 8, and the 12, to be able to see those angles, to be able to coach those and get more of that just kinesthetic awareness for those athletes. Because if you do everything fast, they have no idea. You say, how'd that feel? Or, did you feel like you had control and you could redirect in any position from where you're currently at? Do you feel like you have control of your center mass? They have no idea if it's really fast. So if you slow it down, they're more aware of it. I just see it as the motor skill continuum, right? There's always that subconscious dysfunction. Can we make that a conscious dysfunction? Can you at least be aware of you're probably not in the best position? Here's what that position should look like and feel like, and then continue to expose them to that. I think is probably the most important thing we can do.
Ted, bringing you back in from a technical aspect, and Mark's mentioned a couple there, excessive trunk lean been one major one. Is there any other technical aspects that you're drilling in with you guys when it comes to effective deceleration?
Yeah, same thing. I think coming back to putting them in a proper position, because once again, I'll revisit center of mass. We're trying to isolate where the center of mass should be in those moments of rapid deceleration. So for us, we start so that they can learn the position, and also anatomically, we're strengthening the structures and the musculature that's going to be called upon to get them in that position. So teach them what that position feels like. And then when you can get them into a situation like Mark's talking about, you progress into movement, but then utilizing something like video to actually back it up. So we'll do a lot of that, whether it's Dari system, or even just capturing on an iPhone, on an iPad, and saying, all right, let's go through this. And it could be a sub-maximal effort, but having that quick response where I hold up an iPad, walk them through it, and I'll say, remember the wall drill that we did last week? Remember what that position felt like? Look at your upper body lean. Does that look like the same angle that we were in? No. Okay, let's reproduce that one. Let's redo it, and let's get you back into it. And usually most of our athletes these days are visual learners, just like me, and most of us all are. They go through that rep and it's cleaned up at least within 50% that next rep. Then you rep it again, it's usually cleaned up even more. So for me, using that video evidence to show them what the position is, but it starts with the education of get them in the position, teach them what it feels like, make sure that they ingrain that, bring in a neural pathway of what does this feel like? What is activating? What does my musculature feel like from this position? And then produce that again at a sub-maximal rate. And then eventually you're going to produce that at a maximal rate.
I'd say for us, from a coaching cue standpoint, to your point of like, what are we looking at? What position do we want them to be in? We probably cue and coach the shin angle more than anything else. Because obviously you need your base of support outside of your center of mass to create a direct line of force to the direction that you're going to go. So, we always make sure they understand what a neutral shin angle is. So completely vertical, what a positive, so positive being the direction that we know we're going to go because it's a predetermined drill. And then obviously a negative shin angle where they have to, they're in a disadvantageous position to receive those braking forces. And then it's going to take them significantly longer and more energy to redirect back to that positive position. So shin angle is a big one that we really coach. And I think athletes respond well to.
I think that's probably the most important one too. To Mark's point, you got to coach it, and how we overcoach that intentionally. So when you're in the weight room, if we're doing a lateral lunge, I'm talking to you about your shin angle because I want you to understand that terminology. So when I do get you into a cutting position, you understand, remember what we're talking about, shin angle. Where's your knee in relation to your foot? All right, how does that feel? And how did you hip hinge into that? Where's your hip at in relationship to the knee, to the ankle? So for me, it's all about the shin angle. And if we're doing a squat pattern, if you're on a belt squat, vertical shin angle, this is what that feels like. Continuing to replicate those terminologies and those verbiages every time that you can. I've found a lot of success, and that's killing them with the same words that we're going to bring into the movement.
Perfect. Cheers, guys. Damian, last but not least on this, from a research perspective, I know you were nodding along there when it comes to the shin angle from Mark and Ted. Yeah, anything else?
Yeah, just on the shin angle, one thing I find that's quite useful for that with the decelerations is just contrasting it with like a resisted acceleration and then coming into an assisted deceleration. So using band assisted, I think it's a really powerful way just to get that feeling of the positive shin angle during deceleration. The ability to slow the movement down and get the athlete to feel that the braking forces on each limb. And that's what I would call braking steps, assisted braking steps. Just slow the movement right down. Really heavy assisted pulling. So it's slow movement, but it's forcing the athlete to feel the brakes and to feel that positive shin angle. And if you combine that with acceleration, you can get that real feeling of the difference between the two. So yeah, from a research perspective on the field, there is very little being done, very little. I would probably say you can count on two fingers, I think, how many papers have been done. There's not much, particularly intervention studies, which have been done over a 4 or 5, 6 week period, to see how well that training intervention is transferring to improve deceleration. So that's definitely an area of future research that's needed, using some of the strategies that we've been talking about tonight. From a field-based perspective, again, I've got it on a continuum from the foundation braking exercises to developmental, and then to the braking performance exercises. So the developmental and the foundation exercises, it could just be doing a straight pre-planned horizontal deceleration and manipulating the speed at which they start that deceleration, or manipulating the distance what they've got to decelerate over, depending on the progression of the athlete and where the athlete is. And then as we get to the other side of the continuum, it's very highly chaotic braking under the specific demands of the competition. So can they then use those deceleration qualities in highly specific movements, such as small-sided games, or unanticipated reactive deceleration drills that you can set up as a coach. For example, 1v1 type scenarios or 2v2 type scenarios, and then just building constraints to try and force different angles of change of direction, where we can then manipulate the deceleration demands as well of that drill. So yeah, that's I think from a field-based perspective, very, very recommend the band assisted approaches and manipulating the assisted load, which you can do really well with band assisted stuff. But if you want to get really, really specific, technologies like 1080 sprint offer a real precise loading strategy for deceleration as well as acceleration. So I think that's where you can get really powerful assisted and resisted change of direction movements, and where you could probably see some really good changes in your athletes' deceleration and change of direction qualities. So that'd be the field base for me.
Cool.
I think Damian brings up a really good point, because really most of the time, again, if you're training in a team setting is where it gets, I think, difficult. But to Damian's point, most of us are probably already doing band resisted A marches and A skips and runs. So why not just still keep that band around the waist and provide a slingshot position, or again, a band assisted and overload that braking force. Same thing with medicine balls. Most of us are doing medicine ball throws and throw to sprint. Why not use that medicine ball to provide an overload on that deceleration, that cut position? Bullet belts, like a release belt, we're probably doing those for sprints and for acceleration. We can still use that for deceleration to, again, provide a higher braking load or braking impulse, put them at speeds much above probably what they would test at, just because they know they have to brake. Let's provide them those higher forces, those higher speeds through those implements that we're probably already using anyways.
Perfect. Right. 7 minutes left before I let you guys go. Got a couple of questions that have come in. So Ben, hope it's all right calling me Ben rather than Benjamin. With regards to monitoring deceleration exposure in training or games for team sport athletes, do you have any thoughts on arbitrary thresholds or individualized based on maximal deceleration effort? I forgot to say, if you've got a question, make sure you let me know who to direct it at. So what I'm going to do is chuck it out there and see if any of you want to tackle that one. Who's going to mute the mic? Unmute the mic even.
I'll chip in on that one, Rob.
Okay.
It's a question which I've heard a lot of people ask recently. So yeah, a good question, Ben. And again, I think it's a really important question because obviously we've talked about the forces that we're seeing in deceleration activities. We talked about the frequency. So it's really important that we get this monitoring precision and get it right on an individual basis. The arbitrary thresholds, I think, is where I see most of the work at the minute. Typically using frequencies above for high intensity decelerations, above 3 meters per second squared, typically. And I think that probably is, I don't think it's a bad threshold, to be honest, but I think as we've started talking about tonight, we can probably see some decelerations up at 8, 9, 10 meters per second squared, depending on how you measure it. And I think this is the problem with GPS in terms of the differences which GPS devices have got in terms of how they're quantifying deceleration. And it's a massive black hole, really, in terms of the differences that are existing at the minute and how that deceleration count is being counted. So I think that's really, really important, because I think a lot of some of these deceleration counts might not even be occurring during a horizontal deceleration, for example. There could be impacts or other movements that the athlete's doing. So I think from a relative perspective, I think it would be nice to see some work in that area, but it is really, I think it's a lot harder than acceleration in terms of making it relative to a maximal acceleration capacity. So yeah, it's an area which I'm certainly thinking about, but I haven't got the answers to that at the minute of how you'd make it relative. What you could do is do a maximum deceleration test and take it off that for each athlete. But then it's the logistics of having to keep repeating that and making sure that you've got those values correct throughout the season. So I think it is a difficult one. Maybe the in situ type profiling that we're seeing with acceleration could be an answer there for the deceleration area as well, in terms of just getting that maximal deceleration from match play and making it relative to that on an individual basis. So yeah, just a couple of options which are in my mind at the minute in that area.
Cool. Couple minutes left. I'm going to go with David's question. There's a couple of parts to that, but one thing, there might be a replication of what we've discussed anyway, but I think to cover that off specifically would be cool. To what extent does fatigue influence braking strategy? And is this tolerance to repeated efforts something you would train with specific deceleration sessions, or just leave to the within a component of the sport practice? Mark, Ted, yes, Ted.
Yeah, I'll jump in because Damian said something early that kind of triggered this, and this is specifically with his research around American football versus other sports. Because one of the first things that I've found is a huge trend in practical application when our guys' deceleration numbers, specifically higher deceleration, go down. Typically, that athlete is in a heightened neuromuscular fatigue state. So when I cross-reference that with our force plate data and everything else, including even subjective stuff, just based on sleep, based on fatigue, based on rates of what we're getting there, based on their ratings, I always see the decelerations go down first. And whether it's a 1-to-1 ratio or whatever a typical high level practice would be for us, if I see that go, I typically find the trend in all the other data points to show the same thing or a similar trend. So the metabolic cost of deceleration we know is high. We know, just like throwing, your deceleration forces are going to equivalent to a much higher load. They're going to take a lot more. So for us, the energy deficits that you incur through deceleration training are great. That's why, more similar to what Mark had said, high, low, it depends how you're going to measure this. But for us, we're not going to go through 3 sessions in 3 consecutive days where we're doing heavy deceleration training. I want our athletes to be as fresh as possible, especially early on in an off season when we're training the proper mechanics and the proper positioning of that deceleration, because we know the metabolic cost is so high. So for us, it's very similar to maxing out. You're not going to go in the gym and max out every single workout. Decelerations cost a lot. They cost a lot metabolically and through energy. So for us, it plays almost the biggest role in where we see our athletes and then how we're going to train them and how we're going to adjust our workloads moving forward after those high deceleration days.
Perfect. Mark?
Yeah, I'd say from what we've noticed to the fatigue question, as you start to fatigue, I think in a more fresh state, when you see those higher braking impulses, typically it's a pretty rapid drop in center mass in terms of like the degree angle. As you're more fatigued, you tend to see much more time spent in that early deceleration zone. So it's a much more progressive, lowering of the center of mass strategy, much safer strategy. So there's a lot more like, pre-braking steps before that penultimate step, whatever. You see a lot more of that type of strategy where they just clearly, whether it's from a fatigue standpoint and they just can't overcome those higher forces because of fatigue, or, it's just a protective mechanism for them. They'll tend to spend much more time in early deceleration. So that deceleration distance is significantly increased. And their center of mass isn't a rapid drop. It's a much more progressive, slower drop in center of mass.
Amazing. Good place to finish. And we're bang on the hour as well, according to my PC. So let's end it there. Really appreciate all your time in your respective time zones, middle of the afternoon and late in the evening for you, Damian. Big thanks to all the questions that Kevin, Ashley, Ben, David, hopefully we've got to all them and covered them. But thank you very much, you three. Really appreciate your time. And I'll let you get on with your days. Thanks again.